So
This meeting is being recorded.
Okay, Assalamu alaikum, everyone. So we have our guest speaker, Bassam Khan today. He's going to go over blockchain. The topic, I think, from the title says demystifying blockchain. So we would like to hear more from the experts. So go ahead, Bassam.
perfect. Well, assalamu alaikum. Thanks for the opportunity to like present over here. I'm really excited to like talk to you all and explain how like blockchain has been changing the world. Let me put it this way, um, that right now the internet is at an inflection point, right? The internet which we know of today, where you are like pretty much like creating content and viewing back content, right? That whole change, I mean, that like whole concept is going to change into a world where any content which you own, which you create, you actually own that content and you can monetize that like content. And then at the same time, there will be no central governance of any data which you create. The data is going to be governed, distributed like in a pretty like decentralized manner. I'm going to get into the like details of that in a bit, but with that type of change coming, a lot of conventional business models will be challenged over time. So that said, we are in the start of a new beginning, and blockchain is really at the center of it. So a quick about myself. I'm Bassam Khan. I work at Visa. I've been with Visa for some time now, and I'm actually leading quite a bit of new changes coming in the payment ecosystem, primarily around blockchain and cryptocurrencies. So I will try my best to keep this session at a high level and more relevant to your experience and your understanding. But as like things progress, feel free to ask me questions. Feel free to come back to me and talk to me about anything which interests you about blockchain, cryptocurrencies, and the payment space. I'll be happy to sit down with you and answer any questions which you guys may have. So that said, let's just quickly jump into it. I'm actually gonna start the presentation, and at the same time, I'm actually gonna turn on my video to conserve some from the bandwidth here. Alrighty, so let's just start on the presentation. Okay, so in the next 30 minutes or so, I'm gonna maybe, I mean, I will try my best not to extend it to 30 minutes. I mean, I don't want it to turn it into a boring like monologue. But in the next few minutes over here, I'm going to be talking about blockchain. I'm going to explain you guys for how really blockchain works. I'm not going to get into the thick grooves of it, but I'm going to kind of like talk about that how it works, referencing to a more relevant example, right? Second, we're going to talk about cryptocurrencies. Well, what are cryptocurrencies? I mean, how they're really getting created. This session by no means is a kind of like a cryptocurrency trading strategy over here. I'm not going to be talking about cryptocurrencies trading. But honestly, I mean, that's what everybody knows cryptocurrency for, that you can trade them and you can make money out of them. Primarily, you lose money out of them these days. And in the end, we're going to talk about NFT. That's a pretty interesting concept. And this is where I'm going to encourage most of our students over here that learn this technology and in fact, create a project to kind of like sell NFTs, right? And that would be pretty much an assignment towards the end of this session. So that said, let's quickly jump into it. Now, what exactly is a blockchain, right? I'm gonna actually explain that referencing a very academic example. Most of you are students over here. I don't know, I mean, if you all are like computer science students, but something very common with a computer science students learns is a linked list. Now, what exactly is a linked list? Linked list is a special data structure, right? Which kind of like contains data in a node, and it has reference to the data ahead of it, and sometimes the data behind it as well, right? So this little diagram which you see over here, right? You can see that there's something called a block, right? It has some data in it, right? At the same time, it has a reference to the next set of data in front of it, right? And you can see that in the world of blockchains, right? I mean, these are all these blocks which are like containers of information. They're all connected together in a certain sequence, right? So that quote unquote is really a blockchain. So that said, what exactly is blockchain then? Is it just a data structure? Um, I will say yes, it is primarily a data structure, but a very specialized one. It has a lot of special attributes associated with it, and that's what we are going to talk about in a bit. By the way, you guys might also hear this keyword um, uh, uh, pretty much every time when people are talking about like blockchain, you might hear them switching to another word called DLT. So that's called distributed ledger technology. I am going to explain this in a bit, but let's first start talking about an example of how blockchain is useful. Okay, so in this picture over here, I mean, in this slide, I mean, I have a few pictures, so I'm going to talk about them. Um, let's just think about that there is a vote registry system, right? And the vote registry system has a voting program, has kind of like a voting session going on it, right? To kind of like vote for the best meal, right? Food, the cuisine, okay? And in my example, right, I kind of like called out that biryani and nihari are the two cuisines, right? Um, like I mean, two specialty foods, right, which people are voting for. So in this centralized system, right, you can see that there are three users, right, over here, who are casting their votes. T1, T2, T3 are actually, think about them as timestamps at this moment, okay? That user over here, like let's just say this is user one, right? User one casts the vote at T1, user two casts the vote at T2, and user three casts the vote at T3, right? So all these votes which they have casted, right, they go and reside in the database, but by the time they get to the database, the order in which they're saved is T1, T3, and T2, okay? Now that said, if there is a I mean, if this competition is going on, and let's say that the competition, this voting kind of like program going on, right? I mean, if this ends at T2, right? So by the time it ends on T2, right, you can see that there is really no winner over here, right? Sorry. Biryani is the like winner. Why? Because the transaction which was casted at time T3 was actually persisted in the database before T2. Okay, so you can see that the order in which these votes were casted versus the order in which these votes were saved in the database, there is a small discrepancy, and that discrepancy is leading to that biryani is kind of like called out as the like most favorite cuisine over here, right? But in reality, there is a tie, right? If you just look at T1 and T2, right, there's a tie technically. So centralized systems are prone to these kind of discrepancies, right? There are many more um, uh, kind of like discrepancies which happen in centralized systems, right? Especially, I mean, systems, I mean, who are kind of like serving data at pretty huge scales, right? Um, so a lot of like technology, a lot of tools, a lot of like development methodologies have been built over time to protect ourselves from like these kind of issues, right? But blockchain really comes in as an answer to this all, right? So let's take the same example, right, and map it to the world of a blockchain. Okay, so you can see that we have the same three users, right? They are casting their votes, right? By the way, sorry, there's something. If I go back to my picture over here, you can see that there is something called a transaction, right? So like just remember this, and I'm going to talk about this in a bit, right? But just remember that the payload, the message which they're submitting to the server, right? That hey, this is my vote, right? So that message, quote unquote, is called the transaction. So just remember this. I'm going to talk quite a bit over here in the world of blockchain. So now we have these three users, right? They're casting their same votes, right? But this time their votes, instead of going to a centralized system, their votes are going to a decentralized system. Okay. Now, how does the system really works behind the scene, right? You can see that for like user one, user two, user three, right? Their data is going to like different backends, right? Like over here, it was going to like one central system, but now you can see that for user one and user two, their data is going to this node over here, and for user three, their data is going to this node over here, right? And as per this diagram, what I can see is that end of day, the data is stored in the order it was created from here, right? So you can see that T1, T2, T3, the same sequence is stored over here. You can see the votes over here, right? Their timestamps. And if this voting session ends after T2, then you can clearly see that there is no winner over here, right? Now, how does this application how does, I mean, this whole ecosystem works? I mean, how does it make sure that the data which is getting created over here, right, from these users is persisted and presented in the order it was created? Now that's the power of blockchain over here, right? So so before I talk in detail over here, right? I mean, let's talk a few core characteristics of blockchain. Every bit of data which is created on the blockchain, right, is indelible, means that data once created, it can never be erased, it can never be modified, right? So like that's the like first critical thing, right? And it should be true with every centralized system as well, right? But there are like protocols around systems that sometimes you can go in and edit data, sometimes on the behalf of a user, sometimes not on the behalf of a user, right? But blockchain, from the core of it, it says that nope, once data created, the data stays as is, it cannot be changed. Okay. Another very important characteristic of blockchain is that the data is strictly ordered. So data is created in, oops, seems like I kind of like missed out some text over here. But the like data is strictly created in the order it is received. Now, how does that happens? How it happens is, right, that once data is received over here and received over here, right, the data has this hard timestamp. As you can see in this transaction payload, it has a hard timestamp, the vote date time, right? And that's what I have called out over here. The T1 was at 5 minutes, T2 was at 9 minutes 5 seconds, and T3 was at 9 minutes 6 seconds, right? So what happens is that every node which receives this data, they broadcast this data to every other node on the blockchain, right? Now, what does these nodes do, right? These nodes have pretty much the same business logic, right, as it is running over here, right? They take this data and they run it through the same business logic just to make sure that, hey, is it correct data? Is it relevant data, right, to an application running on the blockchain? So that's a step one. Step number two is that these nodes now verify this data, okay? So I'm not going to get into the like grooves of how the whole verification thing works, but think about it, that in order to make sure that this data created is relevant to the blockchain, right? All these nodes have to solve a very tough computation problem, right? And a tough computation problem, just to give you an example, can be something as if that, hey, keep on hashing means that keep on kind of like processing data through an algorithm, right? Until and unless the last 10 digits, let's say, right, of an output is 10. Okay. I mean, just to give you an idea of what kind of like computation they're doing over here, right? That they're solving a mathematical problem and it outputs a number, and they like need to like keep working on this number, right, until the last 10 digits become 10, but sorry, become 0. Okay. So so they're all solving this, right? And as soon as they have solved it, right, the first node to solve it, right, actually claims that, hey, I have solved this problem, right? And I am now going to broadcast it to everybody, right? So now this node, let's say that this node over here solved this problem. So these were the two nodes which got this data. They broadcasted it to all these nodes. All these nodes, like the ones which even received this data, right? All these nodes together are now solving, I mean, not together, sorry, right? Are individually solving a mathematical problem. The one node who solves this problem first says that, hey, I have solved this problem, and now I'm sending you my output, right, to all these nodes. Can you please confirm that I have solved it correctly? So this node, let's say, solved this problem and gave it back to all these nodes. Now, what do these nodes look at? How do they verify that you have solved this correctly? The first thing they check is that, hey, did you solve that mathematical problem we gave you, right? That the last 10 characters should be 0. Done, solved, perfect. Then the other thing they're going to check is that, hey, the data which was received, right? Was it ordered? Was the order maintained? That did you maintain the order of data, right? So all these nodes are going to verify that, right? And once they like look at that, I mean, once they kind of like complete this whole verification process of looking at the computation problem and looking at the order of data created, right? They turn around and confirm that, yes, this guy has solved this problem correctly. So all this data, right, which was received, T1, T2, and T3, this can now be mined to the blockchain. Now, what does mining means over here? Mining is not just solving the computation problem, but mining is now agreeing that, yes, this user has solved this problem. We approve it. Now, let's go ahead and add this data to the blockchain. Okay. So So in a nutshell, right, what did the whole blockchain ecosystem do, right? The blockchain ecosystem, number one, made sure that only the authorized users are creating data. They are, number two, they are creating correct data, right? Number three, the data getting created over here is persisted and presented in the order it is received, right? And this data can never be altered by anybody else, right? So this is what the whole blockchain system did, right? So you can clearly see that this basic problem, right, which we have in the centralized systems, where any data which you are creating, right, there are good chances that it may not end up in the right order, right, or somebody can come and change it, right? Maybe at some time your data access is broken, right? All those problems, right, are solved by the blockchain. Now, blockchain also is not really a silver bullet, right, to solve all these problems, right, which exist in centralized systems. Blockchain themselves have a lot of problems as of today, right? I mean, as I said, that we are in the beginning of the blockchain era. So the blockchain technology itself is evolving, right? The biggest thing which you can hear from like people, I mean, who are actively working on distributed applications on the blockchain, that you're going to hear about that, oh, the cost is too high to kind of like do any operation, right? The network is very slow, because as you can see, right, just going back to this example, you can see that there are these three users creating data. They're all connecting to one system, right? But over here, they are connecting to different systems, and these systems are turning around and sending this data to other backend nodes, right? And these nodes are then running a computation, you know, I mean, like computing this data, right? They're taking their sweet time, right? I mean, they are distributed all around the world, sitting in different geographies. The internet connection maybe over there might be not as like fast, I mean, as you have in some of the other nations, right? So the network, the blockchain network overall is wrapped with a lot of other issues, right? Which are beyond the little problem which we have talked over here. So I'm not going to get into the like details of that, right? I'm just going to go back and read this little section over here, that the data which is created is indelible, means once created, it cannot be like modified, right? Data is globally readable, right? Anybody in the world, right, can come up and say that, hey, I just want to be a node on the blockchain. And the moment you become a node on the blockchain, right, based on what kind of permissions you have on the blockchain, right? I mean, if it's a public blockchain or if it's a private blockchain, right? Pretty much the whole data of the blockchain gets downloaded on your side. So you pretty much have a local copy of the data which is created on the blockchain, right? Then there is something very important, that rule-based rights. And um, actually, I'm going to explain over here. This is important. Look at the centralized system, right? When we submitted your request to the centralized system, what actually happened, right? There is a bunch of code, a bunch of logic behind the centralized system, right, which is running, and which confirms that yes, the data which you have created is correct, right? So that code, think about that code, right, which is now running in the world of blockchain, right, is running in what format? What exactly is that called? I mean, where is that code running? That code, quote unquote, is called the smart contract. So as you can see in my little picture over here, I have showed this little like, I mean, document icon over here. This is the code. This is the logic of the central application running on a decentralized application in the form of a smart contract. Okay. All right. I think I spent a lot of time on this slide. I'm sorry about that. I'm just gonna try to rush through it quickly.
I mean, you don't have to rush through. I mean, do you guys follow what Brother Bassam is going over? Get some idea what is the blockchain versus the regular network? What's so different about it? You guys got an idea? Can you guys thumbs up or thumbs down?
Bassam uncle, actually, I have a question.
Go
Sure,
ahead.
please go ahead.
Yeah, so you said each node basically holds a local copy of all the data.
Yes.
So that means everything holds everything at once. So everything in the chain has all the data within the chain.
Exactly. Yeah.
Okay, so then it wouldn't really matter if one node got, say, deleted off the chain or anything. You wouldn't lose, theoretically, you wouldn't lose any data or anything then. Because
Exactly.
That certainly is a plus point. There are more things, Bassam, you want to go over. What's the benefit of having a data on every node or something?
Well,
yeah,
I mean, first of all, benefit of having data locally on every node is that, first of all, every node can individually work on their data, right? This kind of like gives them more speed, given that the whole network is so distributed, right? And we are asking every node to participate in solving a problem, means that work on one problem together, right? That kind of like becomes really network heavy, right? I mean, that if we just like, I mean, save data in one central location and call all these nodes that, hey, go and fetch the data from these central locations and then work on them, right? That is a pretty like heavy network job, right? So I mean, like network access. So like this is why the blockchain forces that, hey, the data which you want to work on, right? The data which was created by these three users, keep a local copy of this data and then work on it, right? Now, I must also call out that speed is very important. Why? Because out of all these nodes, the node which solves the problem first gets incentivized, right? I mean, that's how in fact like cryptocurrencies are created, that if you like, I mean, going back to my example over here that I just talked about, that this node solved the problem first and then broadcasted it back to every other node that, hey, go ahead and please verify what I have computed, right? So once they verify, this node is going to get incentivized. Now, incentivized, I mean, how do they get like incentivized? That's a very, very different ball game, right? That the like blockchain has a token on it, right? I mean, let's just say that that's a cryptocurrency that once you solve the problem, right, the blockchain is coded to automatically grant you ownership of a little bit of tokens, right, which is cryptocurrency, that, hey, thank you for solving this problem, right? Because all these nodes, they use their local computation power, which is their electricity, the machines that they have put in over there, right, to solve this problem. So like somebody got to pay them, right, for the hard work which they're doing, and that somebody is none other than the whole blockchain itself, right? So it is critical that these nodes keep data very close to them so that they can quickly work on them, right? And at the like same time, everybody is working independently, right? They solve this problem, and then they turn around and they broadcast their solution to the whole network, right? Which kind of like gives an opportunity to the whole network to confirm that, yes, you did a good job, you did the like right job. Now, sometimes there are nodes, right, which might take this data, and they may not really follow, right, the like hard standards which we have on a blockchain, that, hey, don't modify this data. If they modify this data, they're only modifying their local copies, right? And when they turn around and broadcast their computed results to the blockchain will identify that, oh, seems like you changed the main source of data, so we are going to block you. So the blockchain is coded that if they identify nodes which are changing the authenticity of data, then those nodes will automatically be kind of like knocked out of the whole blockchain network.
So this kind of makes it almost impossible to hack the database, because you can only hack maybe one node, and then if you update it, and then when the other nodes will try to update themselves, they will probably block you, right?
Exactly. That if there is any malformed data in any of these nodes, right, I mean, caused by an hacker, right, or through any like malpractice of like dealing with this data, right, then the whole blockchain is going to identify and block that node. Okay.
Good. Anyone else has any questions? Okay, go on, Bassam.
Perfecto. Yeah, I'm gonna try my like best to speed through some of the other slides. I really want to get to your questions, and given that we are a small audience over here, so feel free to like stop me through a session and ask any questions, anything which you're unable to understand. Just ask me again. I'll be happy to sit down and explain as many times it takes. Okay, now let's revisit some of the core characteristics which we established so far, right? The blockchain, always on, right? It is not a central system which can go down for like maintenance, right? The nodes on a blockchain, right? I mean, they are, just think about them, that many systems together are serving up the availability of a particular program, right? The whole voting platform which we have, right? That's not served by one central system, it is served by multiple systems, right? So that said, your voting platform is always on, right? Privacy, we talked about, right? That again, I mean, like how the like authenticity of data is always maintained, right? Resistance to censorship. Now, in a central system, right, this central entity controls that data, right? So many times it is up to them that, I mean, do they want to make this data available further, right? Or they kind of like want to suppress this data, right? That's not something which you can do in blockchain. Data once created on the blockchain will always be there and will always be accessible to anybody who wants to read data off of the blockchain, right? And then again, I mean, trustless computation, verifiable behavior. Um, I actually want to go back to the previous slide, and I want to talk about something very important over here. A little thick concept, but um, if anybody over here is building APIs, let's say, right? Or actually, no, I mean,
Yeah, we are building APIs, by the way. We use REST APIs for our project. So I mean, they are familiar with APIs.
Perfect, perfect. So let's just think about APIs over here for a minute, right? Now, if this T1, T2, T3, right, these users, right, I have intentionally showed that all these users have a mobile phone on them, right? So think about them that they opened up a mobile app, right, which is a voting platform, right, and they casted their votes, right? Now the mobile app turns around and submits this data to the vote registry platform, right, running in the backend, right? How is this communication happening from this mobile phone all the way to this registry, right? This communication is happening over the internet, right? And again, I mean, this is a secure layer, right? It is securely communicating information from a mobile phone to the backend. Why? Because there is some PII, right, personally identifiable information data, right, which is being sent over the like network. So it might be an HTTPS layer, right? Now HTTPS layer behind the scene is using some certificate, right? Now that certificate is making sure that your like a network connection, right, from the client side to the server side is secure, right? So like that's one way. And then when this request securely lands on the backend, right? What is this backend doing, right? The backend is looking at the user, right? User credentials that, okay, this is U1, this guy is registered on the platform, right? And seems like that this user used our app and the app has made a secure connection all the way to the backend, right? And submitted data. So this is how the central system is going to trust this this user, right, by making sure that this user has used a channel which is trusted, right, and it has come over a network, right, which was protected, and the data which they have submitted hasn't been modified through this network journey, right? Now that's how the central system works. Now, how do the decentralized, especially the blockchain systems work? They pretty much work similarly, but they have one very strict concept going on over here, right? The network layer, I'm not gonna kind of like explain again. This again is a mobile app, right? Um, which kind of like, I mean, is like, I mean, it is a mobile app, right, of the like voting platform, right? The data getting transmitted from the mobile app to this node is over HTTPS, right? I'm not going to get into the details of that, but what is something very important over here is that it doesn't care that, hey, is this user already registered on the platform? Like, I mean, like, again, it depends upon your like business logic, right? But let's say that this user was not registered on this particular application, right? This user, what it does is, right, it has a key, right, which is associated with the smart contract. So the smart contract, right, when the smart contract was deployed onto the blockchain, right, it has now two keys associated with it, right? One is the private key, right, which stays with the smart contract, right? Like, I mean, which is private, right? It stays with the owner, right? And then it generates another key, another pair to it called the public key, right? Now this public key being, like, I mean, as the like name says, is public, right? Anybody can get access to it, right? Now you have to use this public key and sign the data. Sign as in, think about it, that you have to encrypt this data, right? You encrypt this data and then send it over this HTTPS network to this node. When the node receives this data, the first thing what it is going to do is it is going to take this encrypted payload and it will decrypt it using the private key. Now, when you decrypt it using the private key, that at that very moment it is proved that the data which you created was using the authorized key for this particular program. Okay, so that fact establishes the trustless computation, that the blockchain really doesn't care about who exactly you are, right? What it cares about is that you have to be using the correct pair of key, right? I mean, like the correct key, which in this case is a public key, right? To sign the data which you are creating and then hand it over to me on the smart contract. So of course, the smart contract, the first thing it's going to do is going to decrypt this data, right, using the private key, and as long as it gets back the data in the right format, it confirms that yes, you are an authorized user accessing my platform, right? And of course, the second thing it is going to do is it is going to validate the data which you're submitting in, right? Just to make sure that, hey, are you submitting all the data which we need, right? And if the answer is no, then it throws back an error, just like any central system does today, right? That is going to give you back an HTTP error, right? That, oh no, this data doesn't look good. Like an HTTP 400 is the standard error, which any system over the internet is going to throw you back and say that, hey, you submitted bad data. Okay.
So, sorry. So what is the smart contract in terms of, is it something parallel to the REST APIs or some kind of a code on the server, or what how do we parallel it with
A
the
smart,
conventional?
yeah. So smart contract is the real business logic. So
Okay.
it is really just like, I mean, how on this vote registry system, right? Behind the scene, you have written APIs, right? Those APIs have if-else business logics, right?
Mhm.
Like, I mean, just to give you an example, right? It has logic that if this user is registered in my like a platform, right, U1, right, and is casting a vote for like one of the entities which are votable, right, and is coming from a known location, like let's say over here I just gave an example as MH high school, right? So the like logic over here on the server side is validating all these inputs, right? And then, like, of course, I mean, processing this data, saving it down into a database and everything, right? So that is like real code, right? The API code, right? The like backend code. So that code, right, is quote unquote the smart contract in the world of a blockchain.
Okay.
So rule-based rights, as long as you comply with the blockchain rules, you can write data. So I mean, this is one of the characteristics of blockchain. Now, what exactly is rule? Rule is nothing but your code, the smart contract.
So what language normally is used to write the smart contracts? Is it
Well, different blockchains, right, follow different programming languages, right? One of the like most renowned programming language is Solidity, right? To kind of like author smart contracts running on Ethereum, right? So
Mhm.
Solidity, you can think about, is kind of like uh, similar to Python, right? I mean, it has like more like, I mean, scripting logic, right? And I mean, I won't say, I mean, it's kind of like a fully functional object-oriented programming language, right? But it is very closer to Python for its scripting support.
Okay.
Python and JavaScript, yeah.
Okay, good. Any questions, guys? Are you guys good? All right.
Okay, perfect. Okay, I'm gonna skip this part of various applications of blockchain at this moment because I think so we are still at a level of we are trying to understand the like basics, right? I quickly want to touch base upon this little picture which I have in the middle, right? Um, there are when we talk about blockchain, anybody who come across, I mean, is writing code for the blockchain, right? You're gonna hear quite a few fancy words from them, right? And even like, I mean, I will talk about myself that I have been writing some Solidity code over the last couple of years, right? Doing a lot of things around blockchain. But many times when I'm talking with people, there is always something new which pops up, right? So the whole paradigm is changing so fast, right? That there are new tools, new methodologies popping up every day, right? But that said, right, um, the kind of like usage of this tool is pretty standard, right? And in this slide, what I did, I just wanted to put out some very common name of very common tools, right? Tools which are think about them as irreplaceable at this moment, right? They will always be there, right? So so first thing is that there is a wallet, right? It's a now what exactly is a wallet, right? A wallet is really an application, right, which is running on your machine, right? I mean, let's go back to our picture over here, right? These phones, right, they have this voting app on them, right? Now this voting app is turning around and integrating with the blockchain, right? Now how is this integration happening, right? This app, right, voting app, right, is technically a wallet, right, which is connecting to a blockchain. Now, the like significance of a wallet is that it is holding a key, right? It is holding that like critical identifier, right, which you have to use, right, to sign any data, to encrypt any data, right, which you are trying to submit to the blockchain, right? So like that like app, right, that module, which quote unquote manages, right, your keys, right, to kind of like to be used when you're trying to integrate with the blockchain, right, is quote unquote called the wallet. Okay, so MetaMask, right, is a software, right, which people use today, right, to very commonly connect with various blockchains, right? It's more known for connecting to the Ethereum blockchain. Okay, so like that's called MetaMask, right? Now, um, anytime, right, you want to connect, to a blockchain, right? Um, just to give you an example, that when your code, right, when you're writing code, sorry, in this app, right, which has to make a backend server call, right? Um, how does it work, right? I will give you an example that if you are writing Java code, right, then there is a library in Java called a REST template. Okay, so you code around the like REST template library, right? You pass an HTTP URL to it, right? And you compile and execute your code, right? And the REST template library is the one which is responsible for opening up an HTTP connection all the way to the backend, right? Now, in the world of blockchain, right, there is something called Web3. Okay, so Web3 is really a collection of libraries, right, which are enabling the integration from the client side, quote unquote, called the wallet, okay, to the blockchain, right, which is really, I mean, a blockchain node, right? That it is like Web3 is a collection of libraries enabling you to connect from the client side to the backend side. Okay, so you guys are gonna hear Web3 pretty commonly. Um, Web3 is also you're gonna hear that the internet which exists today is called Web2, right? And the internet with blockchain is going to enable is called Web3, right? So you will hear Web3 in many places, right? But just for like from a development sense, right? I mean, if you ever want to connect to a blockchain, right, you use Web3 enabled libraries. Okay. There's also something called like EtherRS, right? So like, I mean, this is like Ethereum REST services, right? So these again are a collection of libraries which you can use, right? It all depends upon how comfortable is developer in using Web3 versus EtherRS. EtherRS, again, as the name says, is very specific to Ethereum, whereas Web3 kind of like has libraries to connect to various other blockchains. Okay. Now, that said, how do you really run an Ethereum node, right? So Ethereum is kind of like an application which is running on your on a machine, right? So what exactly is that application called, right? That application is called Infura, right? Or Get is also another kind of like application, right? So you use these tools to actually spin up the Ethereum node, right? And of course, I mean, as a part of spinning up the like Ethereum node, right? I mean, there are various configurations which go into it. That okay, you're a node in which geography, you want to connect to all the other global nodes of the world, right? So I mean, all the like configuration of the network, right? That where are all the other like nodes residing in the world, right? So all that information goes into Infura configurations, okay? And of course, like I mean, once you kind of like install this particular app, right? It doesn't only gives you access to the Ethereum node, it also gives you some tools, right, through which you can deploy your code, which is called the smart contract, right, onto the Ethereum blockchain. Okay. Now, there is another important concept which I want to call out: oracles, right? Oracles, as the like name means, right, that these are data hubs, right? So it's a blockchain, right? I mean, as I said earlier, right, that every node of the blockchain is holding onto the whole data of the blockchain, right? Now you can think about it that as blockchain and apps on the blockchain and data which people are creating on the blockchain, as it grows, right, then that every node is becoming a big giant data repository, right? So it's pretty expensive operations to run, right? So it is not in best interest of many of these nodes to hold on to a lot of like legacy data, right? So what these nodes do is that they turn around and push this data out to entities called oracles, right? So oracles become these offline repositories to hold on to the whole data of the blockchain. And these nodes, they become a little lighter, right? They only hold relevant data which they have to work upon, right? Or kind of like snapshot like data of, let's say, of like two weeks worth of data only, right? I mean, just to give you an example. So these concepts, I really wanted to just throw them on a slide over here, right? And I want you guys to just remember in your mind that they're gonna come so often in front of you, right? So I want you all to just understand that what is MetaMask? MetaMask is a lightweight wallet which you can use on your local machine to connect to any blockchain, right? What is Web3.js? A collection of libraries enabling your app, right? Your Java, your Python app, right? To kind of like connect to a blockchain, right? And Infura and Get, right? These are really the tools to spin up a node, right, on the blockchain. So, so yeah, these are some critical tools to like remember when it comes to working around blockchain. Any questions before I move to the next slide? I will take it as a no.
Yeah, keep moving.
Okay, perfecto. Yeah,
So,
I mean, sorry. I mean,
before-
if this sounds like a thick subject, but frankly speaking, I mean, explaining blockchains is really
I know.
not easy. I will talk about myself. I mean, I've been an engineer for the last like 15 years, and it took me about 1.5 years just to really wrap my head around that how the whole blockchain system works and how I can really convert my non-blockchain centralized governed applications into a blockchain decentralized managed applications. So took a
I have a question.
sure.
What are some like real world situations where blockchains are used besides NFTs in like companies specifically?
Okay, perfect. I think so. The best example would really be just to go back to what I had explained over here, right? That this is a vote registry, right? That every bit of data which is getting created by these users and submitted to the central system, right? To the centralized system, right? The sequence in which this data is created is critical, right? And then at the same time, right, this data is indelible, means that nobody can modify it, right? And I showed you over here that how a decentralized distributed system, right, is serving up all those values that yeah, nobody can like modify that data, and then data is maintained in a strict order. Now, just remember these two key points, right? And now let's talk about where exactly blockchain is getting used today, right? Now, blockchain has a lot of usage, right? But I just want to talk about one thing very important, right? Relevant to the example which I gave you, is the supply chain and logistic monitoring industry, right? So the supply chain industry, right, is wrapped with a lot of these issues where data is created in a pretty odd manner, right? I mean, things go out of sync, right? And when things go out of sync, many times they're not like, I mean, of course, like reported correctly, right? That there is inventory sitting at a port, but the systems are reporting that nope, there is no inventory. Okay, so in the supply chain industry, right? Now what is a supply chain like in industry over here? Let's say that that there's a factory in China which is manufacturing which is manufacturing a product, right? Now that product, right, is going to show up all the way in the US, right, on Amazon. Okay, so what is the whole journey behind the scene, right? The factory manufactures the product, right? It hands over the product to a logistic company, right, which takes it from that from the like product warehouse, right, out to the port, and then from like there it hands over to the port authorities. The port authorities hand it over to a shipping company, right, which kind of like puts that product onto a shipping onto a ship, right? The like ship comes over here in North America, right, and then from the like shipyard it goes on to another distribution company, like I mean to another logistic company, and from like there it shows up all the way at the Amazon warehouse, right? I mean, just to kind of like explain you that how many exchanges happen throughout this whole cycle, right? That you might be just thinking, oh yeah, the manufacturer makes it and then it just shows up in Amazon, but in between there are 10 different entities in between, right? So these 10 entities, right, they are incentivized, right, for like performing their job, right, in a timely fashion, and maintaining the accuracy of this data, right? So the whole like supply chain like industry, I mean, is wrapped with issues where just that many of these vendors in between, right? I mean, just to kind of like save themselves from any like penalties, right, they might just go in and modify the data as per like their needs, right? Nobody's going to hold them accountable, right? Of course, I mean, there are like, I mean, auditing protocols in between, right, which kind of like oversee operations of these entities, right? But at the like same time, I mean, why not somehow build this whole thing in a pretty streamlined manner where anybody can review the state of data, right, for like where the particular product is in its whole life cycle. Okay, so I mean, like this is like one serious implementation of blockchain, right? Many companies are doing it, right? Today if you go to the IBM website, right, you will actually see that IBM has been building out quite a few tools, right? And I mean, many other vendors are like they're like today. And then of course, I mean, there are like cryptocurrencies is over blockchain, right? So I'm going to talk about cryptocurrencies in a bit, right? Real-time IoT operation systems, right? I mean, this is also something important, right? That data getting created in real time, right? I mean, it should be persisted in its right order and quickly made available to everybody else, right? So these are some of the applications of blockchain.
So Basam, how much we have left? We could create another session, maybe do it next week if you think there's still quite a bit left.
I have these 2 slides to go, but I think so the way how we are going, I will say maybe another 15-20 minutes.
What do you guys think? Everyone, you guys want to continue or you guys want to do it next week? So what's your, I mean, we have to go with your flexibility. Are you available next week if we want to continue?
Oh yeah. I will take out time, right? I would really like to sit down and connect with you guys and explain, right?
I think it makes sense then, because this is a quite dry in a way subject, because like you mentioned yourself that it's not easy to explain this technology. It is complicated for sure. So let's give some time for this to get digested, hopefully, and they probably should. I would recommend them to rewatch the recording because I'm recording it and I'm going to share with them. So that they can get a little bit better idea than the first time. Second time, always you learn a little bit more. So I think we should probably push the rest of the stuff to the next week. And if you can, we also would like a lot of these kids would be interested to see how they can convert their gaming PC into something like Ethereum node or some node where they can understand a little bit about mining. If you can add that on top of NFTs, that would be great. Is that something?
Perfect.
Okay.
Yeah. No, I mean, not something I've personally done myself, but I would, of course, like, I mean, as I said over here, right? I mean that once you figure out a way to connect to the like blockchain, right?
Yeah.
Then the blockchain offers you many things, right? You can become a validator node, right? You can become a miner, right? You can also become like, I mean, or you can just deploy your applications on this on the like blockchain, right? So I'll be happy to like dig into it myself, right, and come back and share my like learnings, right, and kind of like work along with you guys, right,
Perfect.
for how really to experience the whole mining and the validation concept of blockchains, right? But one thing which I will say, the fun of blockchain as of right now is really in the NFT world.
Yeah.
Okay. And maybe in the next session, I'm going to talk about it, right?
Okay. I think that's great. Thank you so much, Bassam. It was really useful, and I learned a lot myself, and I believe these guys also learned a lot out of it. And like I said earlier, I would like them to watch the recording again, and that would help us understand a little bit better. I will myself watch the recording. So thanks again, Bassam. So I think we are already over 1 hour. So I am not going to get an update about your progress in the project. So if you guys have any questions, we can meet again maybe tomorrow, because tomorrow is also off for a lot of you. If you guys want, I can, or you guys want to individually meet with me, you guys can let me know, and we can join there. Bassam, are you okay if I add you in the group? If these guys have any questions, they can ask you directly there.
Oh yeah, sure. Please go ahead. I mean, feel free to use my like number. I can even send out my email address. So feel free to send me questions offline. Anything. I'd be happy to like help. Yeah.
Okay. Is there any question anybody has before I end the meeting? So we will cover the phase 2 of the blockchain next week, inshallah. So Jazakallah khair for attending, and Jazakallah Bassam for giving us the intro to the blockchain. Thank you so much.
Well, Yakum, this was a pleasure. I look forward to continuing on the session and helping you guys out, learn a bit on this.
Okay. Allah Hafiz.
All right. Thank you. Assalamu alaikum, everybody.